I'm going to take a different perspective of AI, and I want to introduce this notion of augmented AI. So it's been around for a little while, and it's about a human-centered partnership between the machine and the human user. And it's meant to be the human and the machine working together, and where the machine enhances cognitive performance, including learning, decision making, and new experiences. So if we look at what's the difference, so historically, when people thought about AI, it's about the machine replacing humans. And it was all about creating these kind of autonomous or independent systems. And in augmented AI, we look at leveraging both the strengths of the human and the machine, and the human then works cooperatively and in tandem with the machine. So with augmented AI, we want to build these intelligent machines or software that amplifies rather than replace human cognitive power. So taking this perspective of AI brings about quite a few research challenges, and these are two that we focus on, but of course there's quite a few more. And the one is adaptation, and humans are usually very good at doing this. So it's not just adapting to some kind of dynamic world or system that we're monitoring in the real world, but it's also the user changes. As the user works with machines, users actually change, their knowledge changes, their skills change. So the machine has to also evolve and learn about how the user is evolving and changing. So there's also the notion of cognition, because if the machine has to work in tandem with the human, then the machine must also know how to communicate with the human, must be able to represent knowledge like the way humans do, the processes, the reasoning processes that humans use. But what's, of course, is a lot harder is for the machine to start discovering new scientific knowledge, to replace what scientists do, or the epistemic processes that we use to discover new knowledge. So just to move back a bit, now, of course, AI is dominated by machine learning. I think people are very aware of machine learning and deep learning and things like ChatGPT and all the strides in computer vision and so forth. But in the early 2000s, there was another wave of AI called the semantic wave. And here it used these powerful knowledge-based AI techniques, and this was trying to mimic human reasoning. So this was a lot more human-centered than the current machine learning. So what came out of this community is ways to represent knowledge in a machine-readable way. And the idea then was for the machine, or this intelligent software agent or program, to be able to access all the content on the websites, which was meant for human consumption. So this provided or produced quite a few languages, like the web ontology language, a way for representing and reasoning with knowledge, and to design these intelligent software agents. Now, of course, as we mostly know, AI is dominated by the data-driven AI techniques like machine learning. So if we look at how we would design these human-centered systems, you would see that there's this kind of synergy between the software developer or the machine learning engineer, the AI system, and the user. So the developer designs the AI system, and then, of course, the user uses. And this is a kind of continuous interaction that happens, that the developer adds new features to the AI system or updates it, and then the AI system is constantly interacting with the user. So this idea of this kind of interaction is also it's linked to this human-centered AI, where we can talk about machine thinking fast and slow, and this comes from economics, which says that and cognitive science, which says that humans actually have these two modes of thinking. The one is very fast thinking, it's very reactive thinking to recognize patterns. So we don't really think about what we're doing, we just act. And the other one is this the slow deliberative thinking, where we actually have to reason about and deliberate about what we're doing. And this has a nice synergy between the machine learning, which is pattern recognition, is very fast to recognize patterns, and the slow deliberative thinking, which is more like the logic and the knowledge-based techniques. So what we really think in the future, the AI systems are going to combine both these knowledge-based techniques and also the machine learning. So from a data-centric perspective, it's going to use this kind of bottom-up machine learning to understand the patterns and detect new patterns in data. And then from interacting with the humans, we need this kind of mimicking how humans reason to be able to communicate knowledge and represent knowledge to the humans. And this hybrid AI system is the current thinking in the AI community. So of course, now we can talk about trying to automate knowledge discovery and evolution. And humans are really good at it. AI, this is at the frontier of AI. We haven't really created AI systems that can mimic what a scientist does. And can replace jobs of scientists, if you want to think of it. There have been some attempts, like the robot scientist and the automated statistician, and we've been working on a new type of system, because it's quite an exciting area, and there's a lot of thinking about how humans do science from the philosophy of science. And most recently, there's a new theory of method, about scientific method called ATOM. And this aligns with this idea of a hybrid AI system, which looks at the pattern recognition using machine learning, and then, of course, the deliberation using the knowledge-based techniques. So all of these things are happening in AI, but what's the future? What can we use this in future in South Africa? And we, of course, are a developing country. We have limited resources to invest in this area, and we have competing priorities like health, energy, and so forth. So a month or two ago, we worked with a digital health expert based in South Africa, and we looked at how could we, if we had to remove all constraints, and of course it was quite a fun exercise, how would we reimagine public health in Africa? And we also looked at South Africa in particular. It was completely blue sky, and we came across, so this was with my people in my group, and of course a digital health expert who's got many years of working in Africa. And we not just looked at AI systems, we also looked at 3D digital twins. And how can we combine or leverage all these technologies? And how can we reimagine the public health system? So currently, there's a move to shift health towards just looking at curing health at the point of care, the clinics and physicians and so forth, and moving towards a more preventative health system. And we think that this augmented AI system, especially looking at 3D digital twins, wearables and so forth, the cost of this technology is going to drop. And we could use AI systems to predict adverse health conditions. And there's a lot of work in this area. And we think in the future, this is something worth pursuing. So I'm not going to go into too much detail. Here's our architecture. It's a little bit technical, but it's all about monitoring and both a user and also populations, detecting, looking at the current situations, detecting or predicting what's going to happen. And then this whole kind of rich mechanisms for adapting to what's going on, imagining, predicting what's going to happen, and coming up with possible interventions. And the idea of a 3D digital twin is that all the sensors and all the information will be in this kind of pseudo 3D reality. and the augmented AI system can actually interact and simulate in this kind of 3D pseudo-reality. These kinds of 3D worlds are not blue sky. For example, the city of Cape Town recently provided a kind of 3D model, an interactive 3D model of Table Mountain, where tourists could actually go and navigate Table Mountain. You can Google it. The idea that users who don't have sophisticated knowledge of AI can interact in the system, and the AI is also kind of simulating and showing you what's going to happen, or looking back and trying to figure out the reasons or the causes for what's currently happening. That's quite a powerful mechanism. You can read up more about this in our paper. So augmented AI systems I think are the future. There's still a lot of work to look at human-machine interfaces. There's also some new results on representing mood and emotion, just from looking at your heart rate, which you can measure using a test strap or a watch. So I think that you are going to get more empathetic systems. And of course, if you can create systems that can self-learn and detect and communicate new knowledge, that's of course will be quite helpful. So what we really need, this is quite an ambitious vision, and there's quite a few like this. If we really want to leverage AI, in my view, we need to create national AI ecosystems. There has been some work which actually has looked at AI for sustainable development. So here's one article by the World Economic Forum, and it talks about leadership and champions in the national system, and skills development, and creating an entrepreneurial culture to leverage AI. Here's another paper which says there's lots of interest in the SDGs, but so far these advanced technologies are really untapped, and we need to, of course, try and have initiatives, concrete initiatives, to leverage them a bit more. Here's another one which talks about the importance and the wealth and potential, but again, it's nothing concrete, but it does warn about some of the pitfalls about increasing inequality. We also had a short position piece about this a few years back, and one of the problems that or the three things that or dangers we identified is that the current system, if there's no explicit national strategy, that AI applications will develop in an ad hoc manner. It will be constrained to specific application areas where there's investment. There'll be these startups and niche tech companies that will dominate it. It'll drive up the cost of AI, and again, it will just increase inequality. We do think that you need to create these ecosystems that connect local, regional, and national networks, skills people had mentioned before, and this collaborative platform, which is agile. AI is quite fluid, so you need these kinds of agile platforms. And of course, ways to accelerate innovation and to incorporate new ideas. So where are we as South Africa? So the one thing that I'm involved in is the National Center for AI Research, which was established in 2011. It's across a few South African universities, and it covers quite a broad range of AI research. So this is just to give you an idea. You can, of course, go, if you're interested in this, you can go to the CAIR website. So you can see it's quite a few South African universities. There's also another national research network called NITES, the National Institute for Theoretical and Computational Sciences. This is a lot more broader. Data science is one element, and of course we are trying to work with them. But this idea of creating these kinds of long-standing research networks and platforms and trying to connect them is, I think, a very important one. So CAIR, we've been quite active, but we don't cover all of AI, and there's a lot more going on in the country beyond what we do. So we've had some kind of technology successes. We've contributed to some policies and been a bit active in the international community. And in terms of building the innovation ecosystem in South Africa, we actually aligned to DSI's, the South Africa Science Ministry's decadal plan. We actually, they are one of our funders and supporters. And so we've tried to increase the research productivity of the South African AI community. We've got a local conference. We had a South African delegation going to the big AI conference, which was recently held in Macau. But of course, this is all challenging to set up a national ecosystem. How would you structure it? How will it work? We've had some experience in this in the health space. There's a lot of work done in setting up national health information systems and strategies and ecosystems. And one of the things, and it's not surprising, is to take a middle-out approach. Because it's so fluid, you need to have an agile system. So you need some kind of high-level direction, policies, and coordination from national government. But you also, there's different organizations and structures and competing interests. So you also needed to be space for the bottom-up fluidity to accommodate the differences. And we believe this kind of middle-out approach is the most agile. So some concluding thoughts. It's quite hard to create a national AI ecosystem, especially because of the restricted funding for AI in the national science and technology system. There are some long-standing research networks like CAIR and NITIS. Of course, bridging the gap between academia and industry is challenging. So we need to also innovate around some partnership models. And I think there's some activity in this area. And governments, the NSTF and of course the NRF, which we had the CEO as a previous speaker, is very crucial to creating such an ecosystem. They can the neutral parties which can help coordinate and provide an enabling environment for a vibrant AI economy in South Africa. Thank you very much. That's all from my side.
Sue McKenna says, I find this stuff so exciting, but given where AI is predominantly being developed, is there cause for concern that AI is only learning from one set of people with particular interests and ways of being, and thereby absenting others? And given the politics of state players and vested interests of industry, is it likely a national system could mitigate this?
That's a good question and a real concern. I think this is, for me, it's not surprising where we are at, because we haven't invested, particularly in South Africa, to develop our own AI technology. So if you use technology that comes from elsewhere, it's not easy to just port it or translate it to our local context. And it's not just us that are struggling with this. So if you look at of course, the investment over the last 20 years in some of these other countries where there's very vibrant AI ecosystems. So the concern for me is this happening? Yes, it is. Is the technology appropriate for use in South Africa? Most likely not. But if we don't invest now to be able to create the capacity to create our own technology, this is going to get a lot worse. The other issue, beside of course, we have different demographics and cultural practices, and so that's a big issue. But the other issue is this notion of data, and so that is why, for me, it's very important not to neglect the knowledge-based techniques. If you just focus on the machine learning and the data-driven techniques, I think we are going to basically, fall down a massive hole. So we actually should look at the knowledge, because the knowledge-based techniques, we can create and represent our own knowledge, our cultural practices much easier without first waiting for huge data sets to become available. So I think if you focus on the knowledge base, you can actually offset some of these dangers.
Right. Yes. Could you elaborate a bit on the voice recognition work that you've been doing, the South African accents and so forth?
Yes, so it was actually done by the Northwest University. It's called the Must Lab. They actually were very historically strong in speech technologies, and they were, in my view, had built up world-class expertise in South African languages on the speech side. So we have this in South Africa, is we have these pockets of excellence. And their system, as far as I'm aware, it's led by Prof Marley Darfel. It actually was deployed in Parliament for the transcription. So it was an actual technology that was produced. And there is, beside the speech, and there's still ongoing work in South Africa on the South African languages from the speech side, but there's also natural language processing. Like if you think about ChatGPT, large language models, there's people in South Africa, very strong people, that are working together to create South African corpuses of text for natural language processing. So there is some work, but in my view, again, of course, these are under-resourced, and we need to coordinate to make sure that we don't fall too far behind.
Right. Yes. That sounds very exciting, I must say. Another question here from Gordon Lang. Picking up on Sue's question, is any thought being given to the dominance of the large tech companies and their ownership of AI and its data? And also, just wondering if Prof Moodley is aware of any work with AI in terms of natural ecosystems, as opposed to technological or human ecosystems.
So the first question is a bit easier, so I'll start with it. And so the first question, in fact, this is my big concern. I think the tech companies are clearly dominating the space, and I think it's going to get far worse. So whatever we have now, there's an acceleration. So whatever inequality, they are just going to get a lot more powerful. They are going to increase their presence in South Africa because we all use Google and ChatGPT and all of those things. And again, so what should we do about it? Create a national AI ecosystem, create our own platforms. Other countries have created their own platforms, not to replace, but at least to have something that is South African that we all share towards, so that it's for the public good. So we call these the reference platforms. So for me, that's very crucial. Like, for example, the speech technologies, so I think that requires coordination and some investment. The next one, I don't understand the question about is it biological ecosystems?
Natural ecosystems. I suppose the concern is about preserving natural ecosystems.
Okay, I get it. So I'm not I don't work in the area. But I do know that we've done in our center, we have worked with we've used AI systems for example, in biodiversity. And we've worked with the natural history museums. There's a guy in the South African Institute for Aquatic Biodiversity. His name is Willem Kutzer. And he looked at using AI systems for detecting for ecological networks to assist with generating ecological networks. And Willem's published on this, and I think he's probably one of the earlier kind of explorers of AI in the biodiversity area in South Africa. But I don't think I've done justice to the question. I need probably a little bit more clarity.